Hi guys, welcome back. After so much math, I feel like I just need to get the F word out of my system. Ready? 1, 2, 3. Factor. Cool. Alright, it's out, so let's do this. Okay, so as the title suggests, we are going to continue our factoring unit. First, we're going to open it up with the general rundown in terms of how to factor. To minimize the length of this video, we're only going to cover we are only going to cover one of these case scenarios. So regardless of how you factor, whether you factor how we have been doing it in class or using another technique, the prerequisite step is always to watch out for common factors. What happens if you don't watch out for common factors? What happens if you don't watch out for common factors from the start? Well, nothing. You're just gonna work with things that are larger than needed, and then you're gonna have to factor at the end, the GCF. But love yourself, watch out for common factors or GCF. Now, what strategy should you use or are you going to use to factor? The strategy that you're going to use to factor is based on how many terms you have. If you have a binomial and there's a minus in the middle, then check to see if you have a difference of squares. So we say difference of squares because we're subtracting two squared terms. If this is your question, then that's your answer. So this is like the multiplication shortcut but backwards. New to your life. What if we don't have a difference of squares? If you don't have a difference of squares and you still have that minus, then check to see if you have difference of cubes. So new to your life. Binomial minus, if you have difference of cubes, if this is your question, that's your answer. Cool. Now, what if you have a binomial and there's a plus in the middle? If you have binomial plus, we don't have two options. We just have one option. So if you have binomial plus, then check to see if you have sum of cubes. So if this is your question, that's your answer. Okay. What if you have a trinomial? Then handle it however you can. So let's do this. Oh, sorry. Fourth case scenario. I think I lost track. What if you have a 4-term polynomial? If you have 4 terms, then I need you to factor by grouping. Okay. So for this problem, we're going to do 4 problems and then we're out. Okay, so bear with me. Okay, so the directions, the same ones you're going to see until we hit the next chapter, which is factor completely. I want to point out that it doesn't say what strategy you have to use to factor, so just factor however you want. So this is our first problem. So we have x squared minus 12x plus 36. X squared minus 12x plus 36. Okay, so prerequisite step is to watch out for common factors. Our terms don't have any factors in common other than 1, so we're good. Cool. How many terms do we have? 3. Alright, so let's do this. If we have a trinomial, I'm really crossing my fingers and hoping that the leading coefficient is 1, and it is. Cool. If the leading coefficient is 1, we do not have to use the AC method. If you're like, no, if you are like, no, I'm AC method for life, then go for it. But for me, I try to avoid the AC method unless I really need it. Okay. Trinomial, leading coefficient 1. Let's go ahead, throw down those parentheses. What am I talking about? Oh, that means you didn't watch my other videos. Let's go ahead, throw down parentheses and work on getting the product of the first terms. The product of the first term should give us x squared. So let's put our fingers in the first lot of each binomial and handle it. So to get that x squared or the product of the first terms, we're going to use variable times itself. To complete the binomial factors, we want factors of c that add up to b. If you feel comfortable to just write the answer, go for it. But you know my speech, I love to speak to myself, so I will always do the X game even if I can do it in my head. So we want factors of c that add up to b. Okay, factors of 36 that add up to negative 12. We keep our cool, and that's going to be negative 6 and negative 6. So let's check it. Product is 36, sum is negative 12, so we're good. So because the leading coefficient is 1, we're just going to plug him in the binomial factors. So since one side number is negative 6, then one binomial should read x minus 6. Since the other side number is negative 6, then the other binomial should also read x minus 6. Can we factor more? And the answer is no. X and 6 have no factors in common other than 1. Same speech for the same binomial. So if you give me this on the test, I'm going to give you full credit. Cool. But then the book, you know, they want to save money on the ink. They want to save money on ink. Well, that's what I say. I don't really know why. But the book says, you know what? why don't you just go ahead, use exponents for repeated factors? I don't really care, okay? So the answer is pretty much 2 factors of x minus 6. Whether you use exponents for repeated factors or you do not, you're going to get full credit. Cool. Alright, 4 problems. That's 1. 3 more to go. Problem B. So we have 4x squared plus 12x plus 9. Oh, where's the special factoring technique? Am I lying to you? No, I'm because of the title. No, I'm not, but baby steps. But I'll get you in problem C. Trust me. All right. So we got a trinomial. Prerequisite step. Watch out for common factors. There aren't any. Okay. Trinomial. Is the leading coefficient 1? It is not, okay? Because the leading coefficient is not 1, then we're going to go ahead and use the AC method or whatever technique you came to class with. Or you Googled or YouTube, same difference, okay? So for my peace of mind, let me label ABC. So leading coefficient is 4, that's our A. Coefficient of the middle term is 12, that's our B. Constant term is 9, that's our C. Product of A and C, namely 4 and 9, will give us 36. Value of B is 12. So we want factors of 36 that add up to 12. So I think that's 6 and 6, but let me check it. Okay, is it? Are they the same numbers? Oh yeah, sorry, I was having a moment. Okay, I just realized we got 36 and 12, but one is negative. I thought I had different numbers. So let's check it. Product is 36, sum is 12. We're good. Okay, so remember, because the leading coefficient is not 1, then we're going to go ahead and use the AC method. Because the leading coefficient is not 1, we have to use the AC method, so we cannot be quick to throw down parentheses. Let's go ahead and split the middle term. Okay, variable part of the middle term reads x, so when we split it, we will replace it with 6x and 6x. Okay, yeah, that didn't look so nice. Sorry, I was trying to be cool, but no, don't be cool, be right. All right, so let's do this. So for the AC method, you do your corresponding x game if you want. You want factors of AC that add up to B. Let's split that middle term. So the first term and the last term stay as is. It's the middle term that has to be split. So we're gonna replace it with 6x plus another 6x. So plus 6x, and then we bring down the rest of the problem. So remember, the gist of the AC method is to split the middle term so you can have 4 terms and then factor by grouping. So let's group the first 2 and then we'll group the last 2. When we look at the first group, 4x squared and 6x have a common factor of 2 and an x, or 2x, how normal people speak. And let's show the world what we're left with when we factor out the 2x from the first group. Sorry, I'm having technical difficulties. First term, is this straight? No, okay. First term over common factor, that will leave you with 2x. Second term over common factor, that will give you 3. So one group down, one more to go. Second group, the GCF, I think it's 3. We go ahead, factor out a positive 3 and do this. First term over 3 will give you 2x. Second term over 3 will give you 3. Fantastic. Now, because we checked the x game, then we are expected to have like a peachy solution, meaning like we shouldn't have any hiccups down the way. Like, or in short, the binomial factors should match. Okay, what if they don't match? Then that means your x game is wrong, either because you didn't check it or your setup is wrong. So be careful. So at this point, let's go ahead, factor out the common binomial factor of 2x plus 3, and then we will show the world what we're left with when we factored from the expression. So let's do this. First product divided by 2x plus 3, the 2x plus 3's cancel, and that will leave you with 2x. Second product divided by GCF, the 2x plus 3's cancel, and that will leave you with 3. So we have factored. Again, what does it mean to factor? Factor is just code for write me as a multiplication problem. So we have one, but did we do it all the way? Yeah, because 2x and 3 have no factors in common other than 1. Same binomial factor. So we're going to have the same speech. You can box it as is, or the book answer. they'll have exponents for repeated factors. I really don't care. Students ask me, oh, Restore, like you should use exponents for repeated factors because it's faster. And then I'm like, why? We have the answer. Anything you write thereafter is just gonna slow you down, okay? Unless you went straight to answer, okay? Alright, so we're doing a total of 4 problems. That was 2. Let's go ahead and knock out 3, okay? Problem C. Alright, where am I? Oh, look how spicy. We have 144n squared plus 168n plus 49. Okay, so let's do this prerequisite step. Watch out for common factors. I really don't know if there's a GCF. I'm gonna focus on 49 because factors of 49 aside from 1 in itself is 7. And I believe 7 doesn't go into 144, so I'm not going to waste my time to see if it goes into 168. So with confidence, I'm going to say no GCF other than 1. How many terms do we have? 3. Trinomial. Is the leading coefficient 1? No. Okay, it is not. So because it's not 1, we're going to go ahead and use the AC method. I'll do the X game above. Okay, so we want factors of AC that add up to B. Factors of A, B, C. Factors of AC that add up to B. 144 times 49. Who has a calculator? I don't know, but I know it's a big number. Can I do that on the test? Sure, why not? I did it. Factors of AC that add up to B. Value of B is 168. But since you're not going to be able to sleep tonight, let me go ahead and write the actual product. Okay, so we have, where am I? 144 times 49. I told you, big number, 7,056. So by some miracle, if I do the AC method, you know, because the leading coefficient is not 1, I'm expected to find factors of AC that add up to B. Am I going to put this on the test? Of course I am. That's how we're doing it in class. Okay, now, the general guideline says this. If you got a binomial, handle it. Trinomial, handle it. When should you check to see if you have a perfect square trinomial? Well, why is it called a perfect square trinomial? It is called a perfect square trinomial because we have a trinomial that can be written as a perfect square or the square of something. Okay, so this is just a multiplication shortcut but backwards. When we were talking about squaring a binomial, we had said if we're squaring a binomial of the form a plus b, if this was the question, then this was the answer. If we're squaring a binomial of the form a minus b, if this was the question, then this was the answer. So again, we're just undoing the multiplication. But how do we check to see if we have perfect square trinomial? I'm going to break it down for you. First, I need you to check to see if you have perfect squares at the beginning and at the end. So a squared, b squared. Then, if you do have perfect squares in the beginning and at the end, then I need you to check to see if the middle term is of the form twice ab. Then if that's the case, if you have perfect squares at the end, middle term is of the form twice ab, then you have a perfect square trinomial. And your answer will either factor to, your trinomial will either factor to square of a plus b or square of a minus b. How do I know if it's going to be plus or minus? Well, that will be dictated by the first sign, okay? If the first sign is plus, then I guess you have square of a plus b. If the first sign is minus, then the answer will be square of a minus b. Yeah, that's too many words. Let's put it into practice. Excuse me. Alright, so I'm going to put a little left note. So I'm going to say big numbers. Makes me sad. Okay? So because I have big numbers, I'm going to ask myself, do I have a perfect square trinomial? I'm not defining the variable or writing my answer in a sentence, so I can write funny abbreviations that no one understands aside from me. These are my love notes. Okay, so let me write down the formula. You know, do we have perfect squares at the beginning, at the end? You know, a squared plus b squared. And if so, is the middle term of the form 2ab. Okay, let's copy down the signs. So if this is what we have, then this will be our answer. Square of a something b. The first sign is plus, so it will be square of a plus b. Okay, so that's the formula. If this is our question, that's the answer. So I'm going to do something that I call the mold. Do I have perfect squares at the beginning and at the end? Okay, so let's do this. 144n squared is a perfect square because that's the square of 12n. So we check it right now. Square of 12n, 12n times 12n will give us 144n squared. 49 is a perfect square because that's the square of 7. Fantastic. So again, we have perfect squares at the beginning and at the end. So now, moment of truth. Let's go ahead and do a drum roll. Is the middle term of the form twice AB? So let me label these bases. The first base is A. The first base that we see is 12n. That's like our A. The second base that we see, that's 7. That's like our B. So I say base because, you know, this is base and that's the exponent. So moment of truth. Is the middle term of the form 2AB or twice AB? So I always like to put the 2 and then the product of AB inside. Okay. Product of A and B, namely 12n and 7. Who has a calculator? Is I don't know my times tables. It's 84n. Thank you for that. Okay. So again, we have perfect square at the beginning and at the end. Now I want to know, is the middle term of the form 2AB? Product of A and B is 84n, and when we double it up, that gives us 168n. Okay, so the moral of the story is that we do have a perfect square trinomial. Why? Because we have perfect squares at the beginning and at the end, and the middle term is of the form 2AB. Let's copy down the operations from our problem. So we had said if we have a perfect square trinomial of this form, then this will be our answer. If this is our question, then this will be our answer. So our answer will be square of a plus b. So it'll be square of 12n, first operation, b. What if you're like, oh no, I don't like this perfect square trinomial thing? Then good luck to you, or find another technique. Okay, cool. Alright, so I said we were going to do 4 problems. This is number 3. Let's go ahead and knock out number 4. Okay, problem D. Okay, so problem D, we have 169 x squared minus 234xy. You understood me. Alright, plus 81y squared. Fantastic. So yeah, we have another spicy problem. Welcome to our course. Okay, cool. So this is a pretty brutal problem number wise. So I'm gonna ask myself, do we have a common factor to yank out? So I'm gonna go ahead focus on 169 because factors of 169 aside from 1 in itself is just 13. I know 13 doesn't go into 81, so I'm not going to waste my time to see if it goes into 234. What about the variables? There's no variables to factor out, so unfortunately, there's no GCF to yank out. Sad face, okay? Pretend you can see my sad face. So, when we do the X game, why do we do the X game? So, scratch that. We got a trinomial. Is the leading coefficient 1? It is not. Okay, so let's go ahead and do that X game. Okay, so corresponding X game, we want factors of AC that add up to B. Because the leading coefficient is not 1, then we will use the AC method to factor. Okay, so let's go ahead identify ABC for fake extra credit. Product of A and C, 169 times 81. I don't know. It's just a big number. And I lost my calculator, but you can put the actual product. Okay, actually no, yeah, I don't want you guys to like be mad at me. Okay, product of A and C, 169 times 81 is that. Am I really gonna put this problem on the test? Well, not this one, because you can just copy, you know. But no, yeah, I'm totally gonna put something like this on the test. Okay, So we want factors of AC that add up to B. So factors of 13,689 that add up to B. Now, if I need those side numbers, or if I feel like I can find them quickly, then I would just totally like find them and then proceed with the AC method. But these numbers are way out of my comfort zone, and I think it's gonna take me more than a minute to find them. So for that reason, I'm gonna put a little love note. Big numbers, you know how I feel, sad. But because I have big numbers, I'm gonna ask myself, do I have a perfect square trinomial? This is math in the classroom, okay, so it's pretty predictable. But in the event that it wasn't, then I guess good luck to you, okay? Or come back to it when you're done answering the rest. Okay, so how can we tell if we have a perfect square trinomial? So we have a perfect square trinomial if we have perfect squares at the beginning, at the end. And if so, then we see if we have the middle term is of the form 2ab. Copy the signs from the problem. If this is the case, now we do have a perfect square trinomial, and that will factor to the square of a something b. Square of a plus b, square of a minus b, you copy the first sign, which is minus. Okay, so let's do this. Let's see if we have perfect squares at the beginning, at the end. Okay, so do we have a perfect square at the beginning and at the end? 169x squared is a perfect square because it's the square of 13 times x. And you can check it right now. 13x times 13x, you're a winner. 81y squared is a perfect square because it's the square of 9 times y. So we have perfect square at the beginning, perfect square at the end. Now more, ¿cómo se dice? Oh, sorry, how do you say it? I forget what I'm trying to say. Yeah, alright, cool. So now I want to know, is the middle term of the form 2ab? So I don't know, let's check. Is the middle term of the form 2ab? Okay, the first base is 13x, so that's like our a. The second base is 9y, so that's like our b. Product of ab, 13x times 9y. Oh, I don't have a calculator. It's 7 with 11. Alright, so it'll be 117xy. Okay, product of AB, namely 13x and 9y, will give us 117xy. When we double it up, because that's what we have, 2ab. We got the AB part. Now we need the times 2 part. When we double it up, that will give us 234xy. Oh, look, I'm crying, but this time tears of happiness. Okay, so we had said in the beginning that we had perfect square at the beginning and at the end. Thanks to our hard work, we verified that the middle term is of the form 2ab. Let's copy down the signs, minus, plus. So, oh, I never answered my question. You know, if I ask myself a question, I need to answer it. I can't leave myself hanging. Oh no, I love myself too much. Okay, cool. So, because we have a perfect square trinomial, if this is our question, then that's our answer. Square of a something b. So it'll be square of 13x, first operation, b. Square of 13x minus 9y. Again, you don't have to factor these kinds of problems. Whenever I have trinomials, the first thing that comes to my mind is not like, oh man, is it a perfect square trinomial? Okay, this is how I handle it when it comes to trinomials. Trinomial, is the leading coefficient 1? Yeah, alright, throw down parentheses and do what I gotta do. Trinomial, is the leading coefficient not 1? Is the leading coefficient 1? Answer no? Okay, AC method. Trinomial. Oh my goodness, big numbers? Let's go straight to perfect square trinomial. Maybe it is, maybe it isn't, but at least I tried. Okay, so yeah. So to me, when I have a trinomial, my first reaction is not check to see if it's a perfect square trinomial. I handle it however I can. If the numbers are big, then that's when I check to see if it's a perfect square trinomial. Okay guys, that's my time. We're gonna come up with 2 more videos for more spicy problems. Thanks.